Hello, my very dear students. How are you all? Look, today we are going to study about the colors of chemistry, and the colors which are hidden in you and me, the colors which are hidden in matter, and we are going to study about them by spectrum. So first, we get to know what a spectrum is. Spectrum is a graph that shows the intensity of the radiation at different wavelengths, or the response of the atomic or molecular system to different wavelengths of radiation. So first we see where is radiation around us. The light, with the help of which we are looking everything around us, is a form of energy, and it travels in the space in the form of waves, and these waves are called as radiations. Means when energy travels in wave form, it becomes a radiation. So we are going to study today about the radiations and their colors. So a spectrum is a graph that shows the intensity of the radiation at different wavelengths. Waves are characterized and studied on the basis of their unique properties, wavelengths, and frequency. So here today we are going to study about both of them. Now we see what are the types of radiations around us. And this is very interesting to know that कि हम इन radiations में से, इन एनर्जीज में से सिर्फ एक छोटे से हिस्से को देख रहे हैं जिसको हम विजिबल रीजन में देखते हैं. यानी रेडिएशंस अपने वेवलेंथ के हिसाब से अगर क्लासिफाई की जाएं तो बहुत बड़े वेवलेंथ्स की भी रेडिएशंस हमारे इर्द गिर्द से गुजर रही हैं, जैसे कि रेडियो वेव्स, माइक्रोवेव्स, इंफ्रारेड रेडिएशंस और बहुत स्मॉल रेडिएशंस वेवलेंथ रखने वाली जैसे कि अल्ट्रावायलेट, X-rays and gamma rays. And remember one thing, that we are looking only the visible regions, means the colors we are looking around us are only in ranging between 400 nanometers to 750 nanometers. That's why this region is called as a visible region. So we go ahead and see what are the types of spectrum. Spectrums is of two types. First, continuous spectrum. How we get this continuous spectrum? When light from the sun or the light emitted from the solid is passed through prism, what happens? You see this. When the white light is passed through the prism, it splits and disperses into its component colors. So here you see the component colors of white light, means the white light is composed of 7 colors light in it, and each color of visible spectrum has its own wavelength. So when white light is dispersed into its component, we get something like this. So this kind of a spectrum is obtained. This is called as continuous spectrum because one color is merging into another without any boundary or without any dark space. And the best example to understand this spectrum is the rainbow. And this is the characteristic property of matter in bulk. So when we pass the white light through prism, we get a band of colors in which we cannot see any line of separation or demarcation, and all the 7 component colors are merged into each other. That's why we call it as continuous spectrum. But this is not the case when we pass light by any element or its compound on its excited state. How we do it? When any element or its compound is volatilized on a flame, or the light emitted is seen through any spectrometer, we see different lines on the dark background like this. As we are getting our spectrum in line form. That's why it is called as line spectrum. And this line spectrum is the characteristic of any atom. Like, it is also said that line spectrum is the fingerprint of any spectrum, as in the case of human beings. So we see why we get these lines, because electrons are excited by igniting or by providing energy in the form of flame of light, and through this we get transactions of electrons between levels and we get line spectrum. The next thing, how we can excite any element. Like, suppose this discharge tube is full of hydrogen gas and it is electrified and excited, and the rays which are emitted by hydrogen are passed through the slit and they further pass through the prism and they are separated into different component colors. So we are getting the spectrum in the forms of line. And in further, there are two types of atomic spectrums. Like, one kind is called as atomic emission spectrum. When solids are volatilized or elements in the gaseous state are heated to high temperature, or they are subjected to any electrical discharge, when radiations come out of certain wavelengths and we get a spectrum of bright lines against a dark background. So this is time we are getting bright lines on the dark background, and through these rays are emitted through any atom. That's why it's called as atomic emission spectrum. The second type of a spectrum is obtained when a beam of white light is passed through a gaseous sample and the light is absorbed by the certain elements, and the rest of the light which is not absorbed by the sample then pass through the prism to get absorption spectrum. And this is what we are seeing. All of the bands are there because this band is obtained from the white light, and only certain frequencies are absorbed by the sample. So that's why we are getting dark lines on a colored background. And this is what? This is due to absorption of light by hydrogen. That's why it's called as atomic absorption spectrum. Now when we compare both of the spectrum, this one is absorption, in which certain frequency wavelengths are absorbed by hydrogen sample, and this is what? When we excited hydrogen atom and radiations were emitted out of any atom. So by studying both of the spectrums, we came to know that it is the characteristic of every element. Okay class, I'm leaving you with the hope that this lecture was a really great help to understand the most interesting and colorful topic of this chapter. Read the topic thoroughly from the book, then learn it. Wish you good luck. Take care.